I believe the only reason we age, we could live for 1,000 years otherwise. The only reason we age is that our repair systems become complacent. There are different levels to resetting aging. There are 3 levels that we know of. I could take your blood and read it, and I could tell you roughly when you're going to die.
What?
Yeah, we can do that.
Want to be happy? Build a life, not just a business. Hey, it's Evan Carmichael, and this channel was created to help you overcome the #1 challenge that is holding you back, a lack of belief in yourself. You watch these videos because you know there's something more inside you too. You have Michael Jordan level talent at something. So today, let's live your best believe life and learn the secret to immortality.
So aging actually has been worked on for about 5,000 years or more. And just in the last 20 years, we've come up with a set of hallmarks of aging. There are about 8 of them. And I think many of your viewers will know that there's telomere attrition, the ends of chromosomes get shorter, mitochondria, the power packs, we run out of energy as we get older. There's a list, a long laundry list. And most of the people in my field have said, okay, we've figured out aging. We've got this list, we put it in a nice pie chart, and that's it. But what I'm saying is that why does all that stuff happen? It's not enough just to tick off what happens. You have to understand, is there an upstream cause of all of that? And so in my book and in scientific papers we are now putting out for the scientific community to read as well, what we think is going on is that our bodies are losing essential information as we get older that drives many, if not all, of those hallmarks that we know exist. When we're born, we're 26 billion cells. Each one of those cells knows what it is and what it has to be 80 years later, it and its descendants. And over time, what I'm saying is aging is caused because cells lose their packaging, and then eventually cells lose their identity. Disease ensues, cells check out, they become zombie-like, and then
senescence, right?
Senescence, and then our organs fail, and we die. But until recently, we had no idea why that was happening.
And so why is it happening?
Well, so the packaging's the really important part because much like the software runs the code, the epigenome controls which genes are on and off. And if you stress the system, and by that I mean biological stress, and the biggest stress you can cause to a cell is to break its chromosome because it's going to die if it doesn't fix it, or worse, for the body, you get a tumor. So the cell has to hunker down, stop dividing, arrest just about everything it's doing, and then try to repair that broken DNA. But in doing so, it has to do 2 things. First of all, it has to take proteins from somewhere else that are doing a good job keeping the cell from functioning, or making sure the cell's functioning correctly. And those proteins are used by the cell to repair the DNA that's broken. But also what's happening at the break is that that's all opening up as well, because you remember, if you break a DNA and it's spooled up, you can't fix it, you can't glue it back together unless you unpack it, stick it back together, and then you've got to repack it. So this movement of proteins and the unpacking, repacking of the DNA, I believe, leads to cells losing that original youthful, what we call a gene expression pattern of how the genes are turned on and off. And nerve cells, as they get older, lose their ability to stay nerve cells, and liver cells lose their identity as liver cells.
So one, I want to know from a lifestyle perspective, what are we doing that's speeding that up? And then 2, what can we do from a lifestyle perspective to begin slowing that down or reversing it?
Well, so I've been studying these enzymes, the sirtuins. We have 7 in our bodies. I've been studying them for about 25 years. And what we've learned is that they respond to the cellular environment. There's a chemical that they require for gas. Think of them as the fuel, called NAD. And there's another molecule that is like the accelerator on the enzymes that makes them go even faster, and that's one of them is called resveratrol, which we discovered years ago from red wine. And together they actually do really great things on these enzymes and make them keep the body younger at least. For 25 years we've been studying mostly animals and even little fungi, yeast cells. And what we've learned from those studies is that these are largely involved in responding to when organisms are under threat of survival. So how do you make the body feel like it's under threat? Adversity. So one is run a lot, or at least become out of breath. A few times a week, your body will say, "Oh man, we had to outpace one of those saber-toothed cats again." Got to build up the body. The other is to be hungry, either a couple of times a week or every day. Skip a meal or 2, and then your body will turn on these sirtuins, make more of that fuel, NAD, for the enzymes, and we think that's what's in part responsible for the health benefits of those lifestyle choices. What you want to do is get the body to fear adversity and the future, but not enough to cause lasting damage or the unspooling of the DNA that'll lead to disease and eventually death. So you don't want to overdo it. You want to be a little bit puffed, you want to be a little bit hungry, but of course starvation, malnutrition is not going to make you live longer. So it's a fine line, and what we've learned from many animal studies and increasing numbers of clinical trials in humans is that you want to pulse it, let the body recover, not constant. We used to make animals go hungry all their lives, and it worked, but it actually works better if you let them recover, and I think that's the secret. If you take a rodent and reduce its calories by 25% for its whole life, it will live longer, 30%, but it'll be really miserable and aggressive. And that's true for us as well. I've tried calorie restriction for about a week and I gave up. I was pretty angry. But what we discovered, my colleagues discovered, is that it's not just what you eat, it's when you eat that's important. And what's been found is that as long as you have that period of hunger in a mouse, so you can feed them every other day, then they can gorge themselves as much as they want, and they do. They eat about 90% of what a mouse having free access to food would eat. But they have the same longevity benefit as a mouse that's always been hungry. And if that's true, what that means is for us is that we can enjoy life as long as we have that period of hunger once a day or maybe twice a week. And I believe the only reason we age, we could live for 1,000 years otherwise. The only reason we age is that our repair systems become complacent. You mentioned that what is beneficial for you when you're young come back to bite you when you're old. What we think is that these repair systems are very good when we're young. So the idea is, it's called antagonistic pleiotropy, and I think it's right, and that is that we evolve to stay healthy and alive and fit till we're 40, and then the forces of natural selection decline after that because we've essentially bred, we've often had children, but we don't need to stick around beyond that, and building a body that will last 1,000 years is pointless at that, So most species only live as long as they need to reproduce, and then a little bit more. If you're a mouse that could die within 2 years, they only build a body that lasts 2 years. If you're a whale that has no predators, you can live for a couple of 100 years. That makes more sense.
What can we do to reset that biological clock?
Well, there are different levels to resetting aging. There are 3 levels that we know of. The first is pretty easy to reset or to manipulate. These are the proteins that turn genes on and off very quickly. We call them transcription factors. And they basically read a gene and make a protein. That's what they do. That's level 1. That's easy. Go a little bit hungry, that'll change. Level 2 is a little bit harder. The level 2 is not just changing which genes are quickly turned on and off, but actually silencing genes for a long time. And this is where my enzymes that we work on, the sirtuins, come into play. What gets really interesting, and this is something most scientists don't even know about yet, is level 3, the deep layer of aging. There's actually a DNA clock that tells our bodies how old we are. I could take your blood and read it, and I could tell you roughly when you're going to die.
What?
Yeah, we can do that.
What are you looking for?
We're looking for chemical groups that get added and subtracted to our DNA, the long string in the cell. You get chemical modifications in predictable ways as you get older, starting from conception. So even in the womb, even as a kid, even as a teenager, you're aging based on this clock that goes up linearly. And where you fit on that line, it's very accurate. That tells you your biological age.
But how do you know when the person's going to die? Is that just based on
just draw a straight
actuarial
line.
tables? Is it actuarial tables? Oh, the average human lifespan is 86, and is that what you mean? Or could you see something specific in my line that would say, ooh, you're headed for 68, sorry.
No, it's not specific, but what it's based on is machine learning based on thousands of people's code of methylation on the genome and comparing that to their health and their date of death. Now, here's the key. Level 2 aging reset, which we can do by some of the things that I'm doing in my life, and probably you are too, those aren't permanent changes. You can't just do that and expect that take one treatment and you go on living for another 10 years.
Okay.
Because level 2 isn't as permanent. It's somewhat permanent than level 1, but level 3 is truly permanent. You could reset yourself 10 years and then go back and then wait another 10 years and potentially reset the clock again if you know how to do that. And we're just starting to figure out how to do that.
Okay. So level 1, diet, exercise. Cool, got it. Level 2, metformin. You taking metformin?
Right.
Okay, so I've talked about this on the show before, but explain, what is metformin? Why is it prescribed to diabetics? And now why is a seemingly rash of non-diabetic people taking it?
Yeah, so there are 3 main pathways that regulate aging in animals and probably in ourselves. There are the sirtuins that I've talked about a lot today. There's one called mTOR, which responds to how much amino acids how many amino acids are in your body. It will hunker down and protect the body the fewer amino acids it has access to.
Okay.
Okay. Then the third is called AMPK, and this is the energy sensor. When your body has low levels of energy, it will allow the body to hunker down and protect itself from diseases. But why AMPK is worth mentioning is this is one of the targets, as we call it, of the drug metformin. Metformin will activate this AMPK pathway and make the body think that it's hungry when often it's not, and also keep your blood sugar levels more steady.
Why would I, hungry at a cellular level, or I actually experience hunger?
At a cellular level.
Okay.
But it also has an interesting side effect is, for a lot of people, myself included, it's a bit harsh on the stomach, so it also reduces my appetite. But what's great about metformin is that it's been in millions of people for a few decades. So we know the side effects. They're relatively
and
low.
Sorry, really fast. So metformin is creating at a cellular level the sense that I'm hungry, and you're saying that from a hormesis perspective of a little bit of bad, it's like stressing the system, and that's why we think it works?
It is. It's exactly doing that. And so that it actually helps the body respond in a way to boost the energy supply. So one thing it does that's undeniable is it boosts the numbers of mitochondria.
It actually creates additional mitochondria. So your cells are getting more efficient or more able to generate energy?
Right, over the long run. But in the short run, what it does is it actually poisons part of the mitochondria. So it's a little bit of poison that leads to benefits down the line.
How many days are you taking it? How many days are you not? How often are you exercising? How often are you not?
I actually spent a lot of my 30s and 40s not exercising at all. It's crazy, right? Someone like me. But I've become better at it now that I was approaching 50, now I'm 50. So I spend about 4 hours in the gym on the weekend with my son, Benjamin.
Do like 2 hours a day?
No, 4 hours straight, but it's not all exercise.
Okay.
So it's an hour with my trainer, Sean, who does mostly a combination of weights and stretching. Some free weights, some machines. Then it's another hour on my own with my son. We do some treadmill, some more stretching, and essentially just muck around doing stuff that's fun for him. And then we do some yoga downstairs in the gym, a little bit of relaxation. But the best fun part that I really love is at the end, we do a sauna, hot tub, cold bath, sauna, hot tub, cold bath for about an hour. Jesus. And I feel fantastic after that.
Is cold and hot both necessary? What's the difference?
Well, there are a few reasons. One is the high level view is that anything that stresses your body, puts it into a state of shock, is good in the long run. But a little bit of perceived adversity, being a little bit too hot, a little bit too cold, and especially the gradient between those two, which is why we jump from one to the other. The next point is that I've looked at the literature. And at first, when I was prompted by my publisher to look into this scientifically, they said, what about this cryotherapy? What do you think? And a couple of years ago, I had no idea that this was real. It sounded like bullshit to me. But I looked into it, and there are two important things. One is cryotherapy or cold exposure will build up what's called brown fat. We didn't know brown fat existed in humans until about 5 years ago. Typically, it's across your back and in other regions. You can see it with a PET scan, but otherwise it's pretty invisible, just looks like fat. But brown fat's particularly healthy because it has a lot of mitochondria, and we think it also secretes little proteins that tell the rest of the body to be healthy.
In what way to be healthy?
We're not sure yet. We're not sure.
That's interesting. Oh man, I want the answer to that question.
But it certainly revs up your metabolism and will burn energy. If you're looking to stay lean, having a bit of brown fat is all good. So my friend Ray Cronus and I have written on this, and Andrew Bremer at the NIH. We call it the metabolic winter hypothesis. And essentially it's saying that in our lifestyles these days, we're always warm. I'm wearing this jacket. We sleep with the covers on, we turn up the heat. We never get exposed to cold unless we force ourselves to. And we think that that's possibly largely responsible, if not, maybe partly, perhaps largely responsible for the diabetic problem we have.
What?
Okay, so if you're cold at night, you're going to burn a lot more energy staying warm.
Yes.
Turn on your brown fat. Now that's going to keep people lean. If we bundle up and we eat the kind of diets that we see in the supermarket, that's going to be doubly bad for our bodies.
Yeah.
We're warm, we're not losing energy, and we're eating a lot more.
Yeah, this stuff is so interesting. Okay, so what's your advice? Whatever you're about to tell me, no, I'm going to do it. So, like, how frequently do I want to be doing it? Is it every day? What's that look like?
Well, what I do is, because I'm busy and I don't have a sauna or a cold tub at home, I subject myself to this stuff for about an hour on Sundays. And what I do is I spend about 15 minutes at 150 degrees Fahrenheit.
Well,
that's reasonably intense, but you get used to it. Then we go into the steam room. We're sitting there chatting. It's great. Temperature is lower in the steam room because humidity is saturated. The roof's dripping on you, hot water.
Right.
But I don't know if the steam helps, but I certainly love the feeling of being in there, and my skin starts to be healthier because, of course, it's cleaning itself out. And then the final thing I do is hot tub, pretty hot water, and then I go and dunk below the water a couple of times in water that's less than 4 degrees Celsius. So that's so cold that it takes your breath away.
Yeah.
Yeah, but it's great.
Interesting. Was there anything else on level 3 that we should know about?
Yes. So work that we've done recently, just in the last year, is finding ways to tweak the cells and the tissues of mice, at least, to reset the clock. We've been working for 10 years, as I said, accelerating the clock. We can drive that hand of the clock forwards now. We cut the DNA of the animal, let it heal, and in doing so, we distract those proteins from where they come from. So we're disturbing this survival circuit so much that we disrupt the spooling of the DNA. And what we got was an old mouse, by every account, based on histology, which is looking at the tissues, based on their physiology. They got gray, they got arthritis, they got heart disease even. And when we look at the molecular clock, that methylation clock, they were 50% older compared to
they had more like clumps everywhere.
Those methyl groups were added.
To the DNA? Yes?
Right.
Okay.
So we had given them heart disease and Alzheimer's or dementia. We'd given them all these diseases, but by measuring the clock, what we had actually done is give them aging. But that was the first step. That took 10 years. The last year, we've been asking, how do you get the hands to go backwards? That's a lot harder. But we were fortunate that the 2012 Nobel Prize was won for the ability to reverse that clock in cells. It's called, it was the prize awarded to Shinya Yamanaka, a Japanese fellow, very smart guy, and he found at least 4 genes that when you put into, say, skin cells of an adult, if you gave me your skin cells, I could go back to the lab and basically clone you. I could take your cells, make a stem cell pool, and I could grow you into a new little liver or a new little kidney. That's all easy. Not easy, but it's doable.
Wow.
It's doable. What that tells us is that those 4 Yamanaka genes can reset age. If I can take someone who's like you, who's in their early 40s, and make a new you, as we've done now for many species, dogs, cats, sheep, monkeys, those animals, we can reset the clock 100%, and those animals actually live a normal lifespan. That tells us that the instructions to be young are still in the cell somewhere, as though there's a backup hard drive that tells the epigenome, those spools, how to go back to be young again and get those methyl groups back to being young again. Not up here, but back there. But don't strip them off too far to be a stem cell, or I'll basically turn you into the world's giant tumor. Right now, the way we do it is we inject a virus called an AAV, and this virus will target certain tissues and deliver the genes to most of the cells in that tissue. For example, we are treating aging of the eye in mice. So we can take an old mouse, we deliver a virus, the AAV, into the eye. It's a tiny little prick. It's the same virus that's used to correct genetic deficiencies in the eye right now, FDA-approved drugs. So this isn't science fiction. This is out there in the world right now. We give it to the old mice. We give them an antibiotic called doxycycline. Okay, same thing you might take if you got Lyme disease. And that turns on these reprogramming factors. We don't use all 4 of the factors, OSKM they're called, because one of them causes cancer, the M. We leave off the M, we put OS and K into the eye, turn it on, leave it for a few weeks, measure what happens to the eye, and those mice can see again like they were young. So we've tested 3 different types of damage to the eye. The first one we did was a Hail Mary. So a lab near ours, across the road, works on rejuvenating the spine and the optic nerve.
Just crazy.
Yeah, because we know as soon as you're a couple of months old, you're not going to regrow a spine. It's one of the first parts of the body that ages, in fact. But jellyfish can regrow, axolotls can regrow an arm. We lose that ability when we're very, very young. So the question was, if we turn the clock back a lot with our OSK genes, will those nerve cells be young enough to regrow back to the brain if we damage them? And that was the experiment. They pinched the back of the optic nerve so that the nerves were defective, and they started to die back towards the brain. Of course, the mice lost their vision. We then turned on our reprogramming factors. We now see that the nerves get young again, wind the clock back, and they regrow back to the brain. We could give ourselves the healing ability that we only had when we were embryos. And you start to think about what could this lead to if we can do this safely, of course safe is the important word, across the body. Imagine one day you could have every cell in your body able to be rejuvenated like that. You cut yourself, you break a bone, you lose your mind, you have a dementia. You take a course of doxycycline for a few weeks and then stop, switch it off again, and you heal.
Now I have a special bonus clip from David on how to get a new lease on life that I think you're going to enjoy. But before that question today, I'm curious, what do you guys think about this style of video? Do you want more along these lines? Is it interesting? Do you never want to see this again? Let me know. Put your thoughts down in the comments below. And if you're still here, you made it this far in the video, I want to celebrate you. Give me a hashtag believe in the comments as well.
We haven't talked about NAD yet. Tell me what NAD is, what are the precursors, how do I supplement for it?
So there are a few on the market. I don't endorse or sell anything, just by the way. Even if you see me online, that's not me. So that said, there's one called NR, which stands for nicotinamide riboside, which is a very early precursor to making NAD in the body. There's an intermediate from that called NMN, not to be confused with M&Ms. Please don't do that. That's not healthy. And then the cell turns NMN into NAD. And you can take all 3 actually, or each one of those 3, and raise NAD levels in animals. And now we're doing, myself and many others are doing human studies, and we've seen that NR, and in my case NMN, does raise the NAD levels of older people and young people alike up to levels that we think you could rarely achieve even with being a marathon runner.
That's crazy. So just to bring this home for people, talk to me about your dad and his N of 1 experimentation with NMN.
Yeah. So my father has been on the same regimen as me, resveratrol for over a decade, the red wine molecule. He's been on metformin longer than me because he was a borderline diabetic, type 2 diabetic, and he's also on NMN now. And he seems to be doing great. He's now 80. When he was in his 70s, he was slowing down. He was starting to say the same things twice, typical 70-year-old. He's doing great now. He's 80. He's got a new lease on life. He started a new career down in Sydney. He's hiking the world right now. He's traveling around America, driving his elderly friend around. Wow. His friend, unfortunately, ended up going to the hospital the last few days. So my father is taking care of his friends who he's seeing on the decline, and he's, if anything, improving every year.
If you want to know why your comfort zone is destroying your life, check out the video right there next to me. I think you'll enjoy it. Continue to believe, and I'll see you there.